Hi, welcome to the Neutral Buoyancy Laboratory at Johnson Space Center, or really close to it, where we are doing some work today with the Orion program. That's our new spaceship that's going to take humans into space next. We're actually working on rescue and recovery operations. This is Tom Walker, who is the lead for rescue and recovery for Orion. He's going to tell us a little bit about that. Thanks so much for joining us, Tom.
Sure, thanks. Thank you very much.
Okay, so rescue and recovery. Why do we need that for Orion?
For Orion, we're going to do a mission in 2014 called Exploration Flight Test 1, where our capsule is going to land off the coast of Baja out in the water. So what we need to do is pick the capsule out of the water, put it on a ship, and bring it back to port.
Okay, and that sounds pretty straightforward, but I guess...
That's the recovery operations.
Yeah.
Because that's an uncrewed flight. When we have a crewed mission in 2021, we'll also be looking at doing setting up for rescue operations. So if there's ever a problem getting to orbit and we landed out in the Atlantic Ocean, we'd send rescue forces out to get the crew out of the vehicle as well.
Okay, so right now we're getting ready for Exploration Flight Test 1. That's coming up in a little less than 2 years now.
That's right.
So, you know, it's 2 years away. Why is it hard? Why are you starting this now?
Why we're starting this now is the way we're going to do recovery on Exploration Flight Test 1 is we're going to have a well-decked ship from the Navy go out to collect this. That ship goes out in the water. It actually lowers a hatch in the back, and we pull the crew module into that hatch into a cradle, kind of like a boat trailer would work. So what we're doing now is we're bringing the Navy experts out and teaching them all the hazards of the capsule, how to interface with the capsule, so we can not only learn how to recover it, teach them how to do it, but also we're building all our equipment. So we're testing out hardware and stuff to interface with the vehicle, and we need time to develop that.
Okay. What kind of questions are you asking? What do you have to consider?
What we have to consider is there is ammonia on the vehicle that vents at landing, so we have to teach them where that danger is and how to stay away from it. There's several areas of the vehicle that are really, really hot at landing, so those are keep out zones that we don't want them getting around. There's also, to get the crew module into the vehicle, there's attach points on the vehicle, 3 of them. So we're teaching them how to hook into those attach points so we can pull the capsule into the vehicle.
Okay.
So we're also developing what's the best hardware to do that. And this training development that we're doing now is all set up for next summer. We're going to go to Norfolk. We're going to get together with the ship's crew and a ship out in the port out there, and we're going to take a capsule like we have back there out into the Chesapeake Bay, and we're actually going to do a practice recovery of it.
Okay.
So that's what all this today is leading towards.
So this is almost the practice for the practice.
This is a practice in a nice, calm environment before we go out and do it in a bay. And then in January of 2014, we're going to go off San Diego. We're going to take a capsule just like that. We're going to take it out into the ocean and do a practice recovery. So we can do it in a real environment, just like we'd see for Exploration Flight Test 1.
Okay. So I guess Orion's landing in water, that's why we're doing all this, and that saves us some weight, right?
That's right. Back in the design phase, that saved us about 1,500 pounds of mass. That's very important to get that off there because we need to be as light as possible since we're going to go all the way out to the moon and beyond.
Okay. And does it make it easier or harder to recover it in the water?
It's actually just a little bit harder to recover it in the water. On the land, it's something you can just walk up to, and you don't have to have like a ship out there and stuff. So it is a little bit easier on land to recover it. There's advantages to water. All the chemicals that we have on board, they're water soluble, so the water actually helps with the chemicals we have on board the vehicle.
Okay, that's interesting. I guess we see land landings with the Soyuz a lot, so we're kind of used to that. But of course, we've seen water landings too. That's how Apollo landed, and so we have experience there. But I take it this is a little different than what we've done in the past.
Yes, this capsule here is a lot bigger than a Soyuz. It's a lot bigger than the Apollo.
Right.
So the landing systems were going to be really heavy to get it to land on land. And since we always protect for aborts with the crew on board, we were always going to have to land in the water. So no matter what, we were going to have to design a system that worked in the water.
Okay, that makes sense. Well, thanks so much for talking with us. And how's the testing going so far?
It's going very well. We're learning a whole lot this week.
All right.
We'll be back at the end of January to go through some other techniques, some contingency operations as well.
Okay. And we're going to talk with somebody else who's working on the test a little later in the hour, so we'll be back. But for now, we'll go back to Mission Control. Thanks so much.